In this video, we are going to talk about the data table approach for case 1.2. Similar to the data table approach for case 1.1, we have three major components. The first one is the parameters. We are going to put those initial value for those parameters in the first component. And the second component is the calculate. In case 1.2, we have two distinct variables. The first one is the selling price, P. The second one is marketing expenditure. We reserve the cell D11 for selling price, P. We reserve D12 for the marketing expenditure, M. In this case, our target is to figure out what is the profit. So we need to have the profit function, P minus C times Q minus M. But in order to get to that point, we need to have the Q, the sale quantity at first. So we specify quantity here. And that will be equation we use. Initial value B times D11 will be the price. To the order of negative D4, that will be the negative epsilon, times the M, marketing expenditure D11, to the order of D5. And we have the profit function specified in the D14. We have D11 will be the price, minus D6 will be the cost, times the quantity, and minus the marketing expenditure in D12. Now let's look at the data table. In the data table at the corner cell, we are going to reserve that for the profit function we specify in the calculate here. So if you look at that, that will be equal to D14. And we specify the value in a column for the selling price, and we specify these cells in the row for the marketing expenditure. And in the middle of this, values will be computed by the data table. So let me start from the scratch for this table. I erase all of the value, and we are going to make this cell equal to the profit function we specify in the calculator. And we are going to prepare the selling price. Right now, let's suppose we have initial value for the selling price equal to 10. And we are going to make the second cell equal to 10 plus the increment we specify over here in I13. But because we do not want the initial increment to change over time, we add $sign in front of the I13 and we said return. You come back again, we have the initial value 10 plus the increment for P, $2 in this cell. And now we can just fill in these cells for the initial prices. Similar thing for working expenditure. If you don't know which value to specify, you can pick any value. I temporarily put that to 100. And we are going to make the second cell equal to the initial value plus increment we specify over here. Again, we need to fix the cell for the increment of I14. So we add $sign in front of I and 14 so that we fix the column and the row at the same time. We have the second value for the max expenditure. If we fill in, we have all this initial value. And now we are going to select the entire table. And we call the data the what if analysis, the data table. In this case, when we have a pop-up window like this, we do have two distinct variables. The one for the row is marketing expenditure, but we do not call any value from here. Instead, we are going to call these cells from the calculator. For the second cell, for the column input, we do have the selling price. So we are going to call it from the calculator again. And we have D11 for the P and D12 for the M. Right now, we have prepared well for the data table. So we just say, OK, and we have those values. Of course, as you can see, the data table is not nice as we initially saw that from the very beginning, because our initial value is has some problems. So as you can see here, the optimal value, the highest value of all the profits here actually appear at the corner. So this information might tell us that 34 for the selling price might be too small for our optimal solution. And the marketing expense of 100 might be too small as well. So we are going to increase both initial value. For example, we can increase 100 to 1,000. And we are going to increase the selling price from 10 to 30. How about that? And we run that. We continue to have the problem. So we are going to increase that again one more time. So we are going to increase that to, for example, to 40. And it starts to shift in. It means the value kind of is much better right now. But it seems the value is still not good for us because the 64 is still too small for us. So we are going to increase this to 60, about 100. Okay, 100 is too big, so we change it to 70. How about that? And it starts to shift in. So right now, we can see that the value is going to be between 90 and 94. So if we can change this value to 80, and we have a better solution for this data table approach. So as you can see, that the initial value is up to change. It's really up to you. And it also depends on whether we are going to have the optimal solution in the middle. If your optimal solution appears at the border, you need to change the initial value of this to bring in the highest value of the profit into the middle of the table.